Translating Problems into Equations, Level 1. In this video, we're going to learn how to translate simple word problems into equations. Word problems are perhaps one of the most feared and hated problems encountered in a typical mathematics course. This is due to a variety of reasons. Many students don't bother reading word problems, and if they do happen to read them, they have a hard time understanding them. The best strategy to tackle on word problems head-on is by having a plan and sticking to it. In general, word problems describe a situation in which certain numbers are related to each other. For the most part, some of these numbers are given in the problem and are considered to be known numbers or quantities. Then you have other numbers for which you have no idea what their values are. These numbers are referred to as unknowns. You must determine their value by using the facts of the problem. In this video, we will practice translating simple word problems that contain two facts involving two unknowns. The following steps will serve as a blueprint to get you started in learning how to translate word problems into equations. In a much later video, we will learn how to find the solution of these word problems by actually solving the equation. For now, we first need to learn how to translate the word problem into an equation. The following 3 steps will serve as a guideline for you to practice translating problems into equations. Step 1. Read the problem carefully. Whenever you see a word problem, just start reading it so you can get an idea of what the problem is about. Decide what the unknowns are. Try to figure out what quantities you need to solve for, or try to figure out for which quantities you have little to no information on. This is usually a telltale sign that the quantity is an unknown. Decide what the facts are. These facts are key in determining how you will relate the quantities with each other. Step 2. Choose a variable to represent the unknowns. Choose a variable for one unknown. Remember that you can choose any letter of the alphabet to represent this unknown. Choose letters that are relevant to the problem, like the first letter of a person's name or object. For example, you can use the variable n to represent the name Newton, or the variable L to represent the length of a rectangle. Or you can just use the letter x to represent your unknown. Write an expression for the other unknown using the variable and one of the facts. In these problems, you will have two unknowns. As a result, you need to figure out how the two variables are related to each other and denote them mathematically by using mathematical operations such as addition, subtraction, multiplication, and division. Step 3. Reread the problem and write an equation. I cannot overemphasize the importance of reading the problem over and over again to make sure you understand all the facts and how they are related to each other. Once you understand the facts, go ahead and use the facts from the problem to write an equation. Alright, let's go over some examples and illustrate how to use these 3 steps. Translate the problem into an equation. Maria has twice as much money as Elena. Together, they have $36. Alright, step 1 is to read the problem carefully and determine the unknowns and the facts. The facts of this problem are represented by the numbered sentences. Notice that in this problem, the unknowns are the amount of money that Maria and Elena each have, since we are not explicitly told how much money they have in their possession. Rather, we are given a relationship of this amount between the two persons. This relationship will be used in step 2. In step 2, we go ahead and assign variables to our unknowns. Many students have a hard time with this step, so let's focus on this step. We already know that our unknowns represent the amount of money that Maria and Elena have. The question we should ask ourselves is how do we algebraically denote them with a variable? From the first sentence, we know that Maria has twice as much money as Elena. We are actually given some kind of relation between Maria's amount and Elena's amount. This is not the case for the amount of money that Elena has. As a rule of thumb, you should always assign the first variable to the quantity for which you have the least amount of information. In this case, we really don't know much about Elena's amount, so let's go ahead and assign this quantity with the letter h. Now, if we use this variable along with the first sentence, we can represent Maria's amount as 2h, for twice as much. All we need to do now is to write an equation relating these two expressions. Notice that in sentence 2, we are told that together, Maria and Elena have $36. This means that if we were to add the amount of money that Maria and Elena have, they would add up to $36. So our equation becomes h plus 2h equals 36. And this is our final answer. We have successfully translated the word problem into an equation. In a later video, we will learn how to solve this equation. For now, we want to practice using these 3 steps, which provide the framework needed so you can tackle these and future word problems. Alright, let's try the next example. A piece of wood 50 inches long is sawed into 2 pieces. One piece is 5 inches longer than the other. If a word problem involves lengths or distances, a sketch can help you visualize and analyze the problem. So feel free to use your artistic skills when solving word problems. Alright, let's start with step 1. We first need to identify our unknowns. We need to figure out for which quantities we have limited or no information. In this case, we really don't know how much each of the individual pieces measure, so our unknowns are the lengths of these 2 pieces of wood. Next, we need to assign variables to our unknowns. Before we do this, we need to first assign a variable to the unknown that contains the least amount of information. From sentence 2, we are told that one piece is 5 inches longer than the other piece. This means that we have one piece that is larger than the other piece. We have a small and a large piece. Looking at the facts from both sentences, we have no information or relation about the smaller piece, so we will assign the variable x to the shorter length. Having assigned a variable to the shortest length, we can use sentence 2 to denote the largest length as x plus 5. Now that we have algebraic expressions for both unknown quantities, we are ready to translate this word problem into an equation. From the first sentence, we know that the original length of this piece of wood was 50 inches. This means that if we were to add the smaller and larger piece, it should equal 50 inches. So we go ahead and add the shortest piece, x, with the longest piece, x plus 5, and set it equal to 50, as follows. So our final answer is x plus the quantity x plus 5 equals 50, and this is our equation. Alright, let's try the final example. Brenda drove 3 times as far as John. Brenda drove 24 miles more than John. Once again, feel free to make a drawing to help you visualize and analyze the problem. The first step is to identify our unknowns. After reading both sentences, we see that we don't know how many miles Brenda or John drove, so these quantities are going to be our unknowns. Next, we need to assign variables to these unknowns. Once again, let's determine which of the 2 unknowns we have little to no information on. Notice that we have sentences that relates Brenda's distance to John's distance, but not the other way around. We have no idea what John's distance is, or how it is related to Brenda's distance, so we will assign this quantity as our variable, and we will use the letter j. Now, an expression for Brenda's distance is going to depend on the sentence that we use. The first sentence says that Brenda's distance is 3 times as far as John. This translates to 3j, or 3 times j. On the other hand, if we use the second sentence, we have that Brenda's distance is 24 more than John's distance. This translates to 24 plus j. Notice that in this example, we have 2 variable expressions that represent Brenda's distance. Now, the last step is to translate these expressions into an equation. Because both sentences relate Brenda's distance with that of John's, it only makes sense that these 2 expressions are equivalent to each other. So we set both expressions equal to each other, as follows. 3j equals 24 plus j. And this is our final equation. In this example, we had two sentences that related a single unknown quantity with the other unknown quantity in two distinct ways. Since both sentences relate the same unknowns, it is natural that both expressions are equivalent to each other. So you go ahead and set them equal to one another. Alright, in our next video, we will continue going over more challenging word problems. Translating problems into equations, Level 2. In this video, we're going to continue translating problems into equations. This time around, we will go over more challenging examples, making sure we use the 3-step plan introduced in the previous video. Alright, let's go over the first example. Translate each problem into an equation. The length of a rectangle is 1 meter more than its width. The perimeter of the rectangle is 60 meters. In this example, we are dealing with a rectangle. So let's go ahead and draw a rectangle to help us visualize and analyze this problem. Recall that the first step is to identify the unknown variables. In this example, the unknown quantities are the length and width of the rectangle. Having identified our unknowns, we now have to assign variables to them. As a rule of thumb, we first want to assign the variable to the quantity for which we have the least amount of information. In this problem, notice that we have a description that relates the length with the width, but we don't have a description that relates the width with the length. This means that we should assign the variable to the width. So let's assign the letter x to it. Now that the width is represented by the variable x, the length of this rectangle would be denoted as the quantity x plus 1, since the length is 1 meter more than the width. Having assigned variables to both unknown quantities, we are ready to translate the word problem into an equation. Notice that we are given that the perimeter of this rectangle is equal to 60 meters. We're going to use this fact in combination with the variable expressions and relate them to form an equation. In order to accomplish this, we need to make use of a formula, specifically the formula for the perimeter of a rectangle. The perimeter is just going to be equal to the sum of all the sides of this rectangle. In other words, twice the length plus twice the width. In this problem, we know that the perimeter is equal to 60. In addition, we also know that the width is represented by the variable x, and the length is represented by the variable expression x plus 1. Substituting these expressions into the formula results in the following equation. 60 equals 2x plus 2 times the quantity x plus 1. And this is our equation. Keep in mind that you might have to use formulas in order to successfully translate a word problem into an equation. It all depends on the type of word problem that you're faced with. Alright, let's try the next example. A triangle has two equal sides, and a third side that is 15 centimeters long. The perimeter of the triangle is 50 centimeters. In this example, we're dealing with a triangle, so let's go ahead and draw a triangle. Let's first identify the unknowns in this problem. Notice that we are given the measurement of one side of the triangle, but have no idea what the measurement of the other two sides are. For this problem, the unknowns are the measurements of these two sides of the triangle. Next, let's assign variables to these unknowns. For the first sentence, we are told that this triangle has two equal sides. So we are actually dealing with an isosceles triangle, a triangle that has two of its sides with the same measurement. This means that we can assign the same variable to both sides, since they are equivalent. So let's assign each side with the variable x as follows. Now it's just a matter of translating these expressions into an equation. We first need to figure out how to relate all of these expressions with one another. Notice that we are told that the perimeter is equal to 50 centimeters. We can relate all the expressions by using the formula for the perimeter of a triangle. We essentially need to add all the sides of the triangle, so our equation will be equal to x plus x plus 15 equals 50. And this is our final answer. Alright, up to this point, we have been going over examples that contain 2 unknowns. Now let's try some examples that contain 3 facts about 3 unknowns. Louis is 3 times as heavy as his luggage. His luggage is 20 pounds heavier than his backpack. The weight of Louis, his luggage, and backpack total 170 pounds. In this example, we actually have 3 unknowns as opposed to 2 unknowns, like in the previous problems. Regardless of the number of unknowns, the procedure is essentially the same. We first need to identify our unknowns. After reading the problem, it is clear that we are dealing with 3 unknowns. The first unknown is Louis's weight. The second unknown is the weight of the luggage. And the third unknown is the weight of the backpack. Having identified the unknowns, we now need to choose a variable and represent the rest of the unknowns with this variable. First, let's figure out which unknown we absolutely have no information about. We know that Louis's weight is 3 times the weight of his luggage. We also know that his luggage is 20 pounds heavier than his backpack. But we have no idea how the backpack is related to the other unknowns. So let's go ahead and represent the weight of his backpack with the variable x. This way, the weight of the luggage can be expressed as x plus 20. And Louis's weight can be expressed as 3 times the weight of the luggage, or using our expressions as 3 times the quantity x plus 20. Now we need to translate these expressions into an equation. In the last sentence, we're told that the combined weight of the luggage, backpack, and Louis's weight is equal to 170 pounds. So we can express this fact as follows. X plus the quantity x plus 20 plus 3 times the quantity x plus 20 equals 170. And this is our equation. When dealing with multiple unknowns, the procedure is essentially the same. Just be a bit more careful and make sure you relate the correct unknowns with one another. Alright, let's go over the next example. Maribel, Dave, and Henry have $180 together. Maribel has 3 times more money than Dave. Dave has 2 times more money than Henry. Similar to the previous problem, we first need to identify all of the unknown quantities. In this particular problem, the unknown quantities are the amount of money that each person has. In this example, we have 3 unknown quantities. Once we have determined the unknown quantities, we are ready to assign variables to them. Let's first determine which unknown quantity we have the least information on. We know that Maribel has 3 times more money than Dave. We also know that Dave has 2 times more money than Henry. But we have no information of how Henry's amount is related to the other 2 amounts. Hence, we will assign the variable x to Henry's amount. This means that Dave's amount will be represented as 2x. And lastly, Maribel's amount will be represented as 6x. Having assigned a variable to each unknown quantity, we are ready to translate the word problem into an equation. We know that if we were to add the amount of all 3 individuals, it would add up to $180. So we can denote this relation as 6x plus 2x plus x equals 180. And this is our equation. Alright, let's go over the final example. A pipe 10 feet long is cut into 3 pieces. One piece is 1 foot longer than the shortest piece, and 2 feet shorter than the longest piece. Alright, this word problem is perhaps the most challenging problem in this video. Let's use everything that we learn to tackle it. Let's first make a drawing of our pipe, broken into 3 pieces. Let's first start by identifying the unknowns. In this example, we have no idea how much each of the pieces measure. So the length of each of the pieces will be our unknowns. Next, let's go ahead and assign variables to each of the unknown lengths. Because we have 3 distinct pieces, we will label them as the shortest, medium, and longest piece, so we can easily distinguish them. From the second sentence, we're told that one piece is 1 foot longer than the shortest piece. So let's go ahead and assign a variable to the shortest piece. Let's assign the variable x. With this assignment, the median piece will be denoted as x plus 1. Finally, we are also given that this same piece, the median piece, is 2 feet shorter than the longest piece. Let's think about this. If the median piece is 2 feet shorter than the longest piece, that means the longer piece is 2 feet longer than the median piece. In other words, it can be denoted as x plus 1, the length of the median piece, plus 2, since it is 2 feet longer. Having assigned the variables to all 3 unknowns, we are ready to translate the word problem into an equation. From the first sentence, we know that the original pipe length was equal to 10. So if we were to add the individual pieces, they should add up to 10. So our final equation is equal to x plus the quantity x plus 1 plus the quantity x plus 1 plus 2 equals 10. Alright, make sure you read the word problem as many times as you need to. You really need to understand the problem before you start identifying unknowns and assigning variables to them. Okay, in our next video, we will expand the skills developed so far and start solving word problems over a given domain.